Any questions? Questions? All right, so I have an issue that I unfortunately need to bring to everyone's attention. So as these assignments are getting more challenging and less routine, there unfortunately seems to be an increase in plagiarism. So I've gotten, for the last homework, several submissions that had large stretches of exactly identical code. And so a reminder, and I put this here on the homework assignments sheet as well, is that when you work, what you turn in has to be your individual work. So it has to be your own intellectual contribution. It's not acceptable that you copy and paste something from some other student. It is not acceptable that you do group work. You must work on your own. So that's a particular issue with Piazza. Can you copy and paste something from Piazza? You can read it from Piazza. And if what's on Piazza is really the one and only way of doing it, by all means copy and paste it, and then put in a comment where you got it from. So that you can simply copy the Piazza URL, and I put an example here, and then that's fine. But you should really only do that if what's on Piazza is like so convincingly and clearly the only reasonable way of doing it that it's worth copying. If there's a long computation on Piazza and there are many other ways of doing it, then you should understand the computation and do it on your own. And this particularly happened with those triangles. So if I look at a couple. So, you know, there'll be people who will be pasting code on Piazza that has, you know, stuff like this here. And now you have to use your judgment. Is this the one and only reasonable way of doing it? And in this case, I would say that probably is, you know, so concise and so reasonable that there's no sense in changing it, and then you can just copy and paste the URL. On the other hand, if one looks at gosh, now I can't find it now. No. Yeah, so if you look at something like this here, and now you look at it and you see here like a minus 15, a plus 15, a plus 4. First of all, you would immediately say, well, that student, poor sucker, is going to lose a few points because those are magic numbers. And so then you can change them to something else. And you can improve that code. There may well be other improvements that, for example, look at it here, how this student here calls set color red, and then calls it again, even though the color has never changed, so it still is red. It is almost always true that when you look at code in Piazza, that it is not perfect code, and that it can and should be improved. So by all means, read through the code, see what you can learn from that code, and then put that learning into place and turn in an improved version. So again, you can copy and paste from Piazza if what's in Piazza is obviously the most reasonable way of doing it. If it is not, you can learn from it and then you can rewrite it in your own way so that it's better than what you found in Piazza. If you simply lift something from Piazza and you do not attribute it to Piazza, then you are plagiarizing, and I will find out because good old Moss tells me. Well, actually, let me take that back. What Moss does is it compares your solutions. If you're the only one who copied it from Piazza, I may not find out. So if you think that everyone else in the class has gotten the message, and you're the only one who wants to cheat in this way, you will probably not be discovered. That's a pretty big risk to take, and if I were you, I would not take that particular risk. What has clearly happened in the last assignment, there were a whole bunch of people who did this. There were also a whole bunch of people who copied from some other source that was not Piazza. I searched on Piazza and it wasn't there, and who had long sequences of totally identical code for computing those triangles. I realized those triangles were hard, and I realized that not everyone started with them early enough. But if you have the choice between not turning in a solution or turning in a solution that draws really horrible triangles, or copying something from a friend, I can only advise you not to do it. I may not find out this time, but if you keep doing it, I'll find out the next time, or the next time, or the next time, because I am running Moss on every single one of these assignments. What will happen is that when I do find out, is I will file a report with that student service where you're then a registered plagiarizer. You will not fail this class, but if it happens again, maybe in another class, then you will likely fail that next class. So you don't want to be registered there. So please take that seriously. The whole point of these programming assignments is not for you to gain a few points in Canvas. The point of these homework assignments is to change your brain. You're not changing your brain by copying another solution. So I apologize to those many students who are doing a great job doing their own homework assignments that I wasted your time for a few minutes, but I needed to say that. All right. If anyone has any questions about what constitutes plagiarism and what is honest and above board behavior, feel free to ask, and I'll be glad to go into as many details as I must. So that homework 6A, the one with the triangles, was kind of trickier than previous ones. Like I said, some of these homeworks are getting harder. And so if you were one of the ones who felt like Saturday afternoon was approaching and you had no clue of doing it, that really does mean you want to start asking earlier. It's not a hard assignment if you know how to do it. And I wish someone had asked me on Wednesday so that I could have told everyone the trick. I forgot about it. So let me just really briefly go over what I had in mind. Oh, and I think I also forgot to post the solution. Hopefully I'll remember to do that when I come back to the office. So the difficulty with this assignment was you have this line that joins these 2 points. And then over here, at the end, you want to draw this triangle. And so clearly what the difficulty is, how do you figure out these 3 points? Now, as it happens, we have a direction vector, dx, dy, that points in the right direction, and that has length 1. It happens to have length 1. Can you see the green? And that's kind of nice, because that means that if you wanted to go from this point here, from the black point to the red point, then let's say the black point was, I think in my solution it is, hang on. It was nu x, nu y. Then you can compute nu x plus some length times dx, and then in the y direction, nu y plus some length, the same length, times dy, and that gets you from the black point to the red point, where length is simply the length of this segment here. So you might set length, I think I chose 15, and then that gets you the red point. Now the other difficulty is, how do you get these two other red points here? And for that, the first thing that works is if you move backwards by the same amount, that'll get you to a point here that I'll draw in some other color, like purple. So to get to the purple point, you subtract these two quantities here. So you compute nu x minus length times dx, nu y minus length times dy. That gets you the purple point by the exact same logic. All right, now you have the purple point here, and now you want to move in perpendicular direction by some amount here, and then by the same, some smaller amount either way. So now how do you move in perpendicular direction? Does anyone know? So this is a very, very useful trick, and that comes in handy in all sorts of times when you need to do these kinds of constructions. If you have a vector dx dy that gets in a particular direction, then the perpendicular directions are minus dy dx or dy minus dx. Because there's one perpendicular direction up or down, except up or down is pretty meaningless because the thing could have been oriented any old way. So these are the two perpendicular directions. And one could think of which one goes in which rotational sense, but we don't care because we actually happen to need those points. So if you move with those vectors by a length of, I used 5, then that gets you the other two red points, and that's all you need. No trigonometry required. Yes? Oh, you turned the bug?
Yeah, I just turned, I mean,
Oh, that's actually,
I turned the graphics, but I mean, I turned it and faced it at an angle directly towards the
you can do that. You can certainly do that. And so that's actually is this thing that had not occurred to me. What, a totally revolutionary way of solving this problem, and that would be to launch another bug, have it move a little bit to the front, and then have it turn by a tiny amount, and have that other bug find out these points. Because if you use yourself, then you lose your space, and then you have to find it again. Yeah? Oh, you changed the. You can change the graphics context, but that is most students find that difficult, so I wasn't going to go into it. That's great if you know how to do that, and feel free to publish your solution actually then, so that people see another way of doing it. But here's the very straightforward solution that uses nothing but really basic line drawing, following a line in a 2D line and using this perpendicular trick. So have a look at my solution. If I don't remember to post it by later this afternoon, complain on Piazza and I'll post it. Any questions about this? Yes? Well, there's no way of moving the unfortunately, in Java, there's no method for making even a triangle or for rotating it. So intuitively, you would say, yeah, I'll make this triangle and I rotate it, but the library gives you no tools for that.
Right now, you change the move method. Is there any other way, like you change the turn method?
Well, the description said to update the move method. But chances are, if you ended up changing the turn method, the grader wouldn't find out because the grader only looks at that diagram. If it came out right, you might luck out. But
If I like change the turn method, and then do I can get the same result? Like,
you might. I've never given it any thought. But I could probably come up with some other a display like where I just call move, move, move 3 times. And then with my solution, you would see the 3 arrows lining up. With your method, if you did it in turn, you wouldn't see any of them. So it's not the intent, it wasn't the intent of the assignment. So the assignment said at the end of the move, draw the position. Other questions? All right. Let me just have a quick look at the next homework to see if there's anything that you should ask me on Wednesday. Yes. So, so the next homework is actually Part B is fairly challenging, and you should come up with some questions on Wednesday. So be sure to go a little bit further in this than simply doing the very simple, fill in the stubs, which is what you're supposed to be doing for the draft. But also ask yourself, how the heck am I going to do this? So that you can put in a question on Wednesday. If no one asks the question, I may just completely blank out and forget about talking about it, which is what happened with that triangle. All right, moving on to the lecture. All right, loops. So we're finally getting to loops. Students tend to find loops difficult because they, until now what you've had is you follow the program, you go from the top down, it says does this step, does this step, does this step, maybe there's a branch. But with a loop, there's many more steps that you have to keep in mind, and you can no longer simply just follow along a step at a time and still reason about the program. So the simplest loop has this form, while, and then some condition, and then some statement. And just like with an if, the statement is commonly a block statement, meaning it's a bunch of individual statements surrounded by braces. So here's this example from the book. We want to know when my bank account has reached a target balance. I'm saving for something, and I want to know how many years do I have to wait to buy myself whatever. And so here you have this very typical loop. The while statement says keep on looping while a condition is true. Here's the condition. We should stay in the loop while the balance is less than the target balance. So there's actually something that's a little bit confusing. When you think about it, you say, I want to have $20,000, and so you're thinking that you're waiting for the balance to be at least $20,000. But when you write the loop, you have to invert that, because you stay in the loop while you don't yet have $20,000. So with loops, you don't think, are we there yet? You have to say, while we are not yet there. So what do we do in the loop? Each time we increment the year counter, and we compute the new interest, and we add the interest to the balance, thereby hopefully growing the balance. So this program here simply puts this loop inside a method. That's this wait for balance method here. So here you see the loop that we've just had. Well, it increments in years because it just wants to keep our life simple. The interest rate is only compounded once a year. I realize that with most bank accounts it would be compounded monthly, but the code looks the same. It's just then the interest rates look so ludicrously small, and it's tedious to do the tracing. What do you mean? Well, all loops are different, so there's no one recipe for a loop. This particular loop says, while we're not at our target, we increment our year counter, and we update the balance. That's what this particular loop does. Other loops have different forms. And there's often the desire on the part of the student to say, give me a recipe for loops, but there is no such thing. All right, so when you use such a loop, where do I have it? Where do I have it? Okay, I guess we'll look at it with a simpler loop in a minute. Well, what I want to say is the way to get through such a loop is to trace it. Over here, the tracing is done in this in this form with these bubble diagrams, which is not what you would do when you trace it on a sheet of paper. You'll see that in a minute. So you figure out what you enter the loop. In this case, balance is 10,500. The target is 20,000 in this example. You increment the years. Now it's 1. oh, sorry, when you entered balance was 10,000, at the end of it, balance was 10,500. Then you go through it again, now you increment the years, you compute the new balance, and eventually, as it turns out, after 15 years, the balance is bigger, and then the condition is tested one more time, no longer true, and the loop exits. So here we have a few examples of very simple loops, and it's worth actually studying these, particularly if you're not very familiar with loops yet. Let's look at this loop here. See if I can make this bigger. So I is 5, while I is greater than 0, we print I. So, and after the printing, we decrement it. So for the first time around, I is 5, we print 5, and now we decrement. Keep in mind that I is now 4. Let me write this down. Now we go back. Is 4 greater than 0? Sure. So we print the 4 that's here, and I is now 3. Then the 3 gets printed, and you can see how this goes. Let's now look at what happens when I is 1. 1 is greater than 0, so the 1 gets printed. I is now 0, and now 0 is no longer greater than 0, and the loop exits. So that's a very typical example here. Now look at the loop over here. The only difference is over here I had an I minus minus, whereas here I have an I plus plus. So here the loop goes 5, 6, 7, 8, 9, 10, and so on. When does it stop? So it stops when I is no longer greater than 0. Yeah, it'll happen when you reach the largest possible integer, which is about 2 billion and change. And at that point, it'll magically switch to negative numbers, and then the loop will actually stop. So it's technically, it's not quite an infinite loop because of the way that integers are represented in Java. But that really is just an accident of how Java does it. If you did this, for example, in Python, where large integers are supported, then the loop would truly be infinite. You know, it's not entirely infinite. At some point, your computer will crumble into dust. And at that point, the computation will also stop, but it could theoretically go on forever. All right, so, and this will happen to you. You will run the program, and the IDE or BlueJ will just sit there. And you'll say, it's frozen. There's a bug in my IDE. And until today, that if the IDE had been frozen, there really would have been a bug in the IDE. But as of today, you can freeze a perfectly good working IDE just by writing a wrong loop. So, congratulations. All right, let's look at another minor variation of this loop here. Here we're saying I equals 5, and then while I greater than 5. Now, 5 is not greater than 5, and so the loop is never even entered. Now, if you think about it, there's nothing really weird about it, but sometimes students find it strange that it can happen that a loop is never even executed once. So if the condition is false at the outset, the loop is just never entered. So here we have another example of a loop that, let's see what happens here. Oh, it doesn't get entered because I is 5, and 5 is not less than 0. But what happens here is sometimes students by accident write a loop where they think about when am I done. They say, well, I'm done when I is less than 0. And you just need to remember the condition here is the one, when should I keep on going, as opposed to when can I be done. And here's my all-time favorite. And the very last one here, notice the semicolon. So when we go back to the definition of a while loop here, in this case we had while and then some condition and then a statement. So the statement in this particular case was the statement consisting of nothing but a semicolon. So this loop checks is I greater or equal than 0, and when it finds it is, then it executes the empty statement. Then it goes back and checks whether I is greater or equal than 0. Well, I was never changed by the empty statement, so of course it is. And so it enters the loop again, does nothing again, checks again, does nothing again, and it keeps on going forever. So it's an infinite loop. And it's kind of mean because why would you ever want this? Couldn't the compiler say, well, this is obviously stupid. Why would you ever want to have an empty statement? But it does happen once in a blue moon that some people want to do this, so the compiler does not know whether you were one of them or not. So be careful with those semicolons. It's an easy mistake to make. Yes? You know, the only time that you ever have the situation that you have a semicolon is that if the body of the loop, in addition to, if the condition of the loop, in addition to testing something, also does some work. And that's really very rare. And it's bad style, too. There's a thing in the book that says, don't do it. But the compiler doesn't know that you're always programming in good style, so it says it's legal. All right. So let's try this out with this beautiful clicker question. How's the network today? Can you get it? The slides? Oh, great. minute. All right, so let's see where we're at here. While false. Oh, let's just see what you guys said. Maybe everyone agrees on it. Okay, so most people said nothing. The code segment has a syntax error. Why don't you tell me what the syntax error is? It's good because I don't know either. Let's just try it out, see what BlueJay says. Yeah, well, that would be a syntax error. All right. And let's hope that's the one that you meant. So I meant system out print on. Hello. So what's that mean? So here what happens is that the condition false is never true, right? The while loop says while a condition is true, just keep on doing it. But false is never true, so the loop is never entered. So what I actually thought, what I would have checked, what I would have crossed on is number 3. What I thought is happening is that, well, while is never entered because false is never true, so it skips the first part and then it prints world. What actually happened is something that I forgot about, that the Java compiler will check whether a condition, when a particular path to the program can never possibly be reached. And so in this case, it's smart enough to realize that the condition false can never be true. In fact, it's the only condition that it knows can never be true. And then it says it's an unreachable statement. So actually, this one is correct. So those of you who answered this, did you know this? If so, pat yourself on the back. Or if you put it into BlueJay, more power to you. All right. So no one would ever want to write while false. Would you ever want to write while true? Well, this would be an infinite loop, right? Because true is always true. The only time that you might want to do this is if you have a situation where you say, if some condition is fulfilled, return. Because the return gets you out of the current method, and including that infinite loop. So only if you have a backdoor exit like that would you want to use while true. But it does sometimes happen that you write a loop like that. So if you don't have the return, then of course you will be trapped in this while true loop. But with the return, it'll work. Okay. Oh, sure. Might as well read a bit of code here. Let me set up the question. Come on, CAFSA. there's only 3 choices on the poll? Oh, that's bad. Let me see if I can. Yeah. All right, it doesn't matter. Yes. Yes, so no, it doesn't throw an exception. So all right, so if rate was set to 0 in the main method, that means in the constructor here, it flowed in here, and it set this rate here to 0 as well. And so let's see what then happens to this loop here. So if rate is 0, then interest is the balance times 0, so it's also 0. So over here it says balance equals balance, so it doesn't change the balance. Well, if it doesn't change the balance, then it'll always stay less than the target balance. And then that would give us an infinite loop. And it looks like that's what just about everyone got. All right. So that doesn't look too difficult. So common error, infinite loops, we've already talked about that. Now, as a practical matter, infinite loops happen usually because one either forgets to make an essential update or because one accidentally puts that essential update in the wrong direction. So over here, I want to wait for 20 years and see how much interest I get in 20 years. But I forgot to put in a years plus plus. Easy mistake to make. I've made it hundreds of times. And in that case, the loop will run forever because years doesn't change. And so you'll notice that your IDE will freeze and you'll need to restart it. Actually, do we have time? Yeah, sure, whatever. Let's just try this really quick. So what variables do we need? We need balance. Double rate. 5. All right, let's compile it. And I'll run it. And as you can see, no answer materializes itself. So now it's useful to know how to tell BlueJ to stop this process. So one way is to turn the computer off and on again. A less drastic way is to right-click on this doohickey here and select Reset Java Virtual Machine. And now it's done. That's why I went through this exercise. So let me just quickly fix it up here, and here put in the years plus plus, which is after all what I wanted. And oops, now when I compile it, then it gives me the answer and says, after 20 years, I have $26,533. All right, so the point of this was to show you what to do in BlueJ if this ever happens to you. Now here I have another mistake that's a very common mistake. For some reason I want to count down, so I've started years 20, and then I want to count them down 19, 18, 17, 16, and so on. But because it's so much more common to write plus plus than minus minus, it's entirely possible that your fingers on autopilot type plus plus. This happens not so much to very beginning programmers, but to those who've been programming for a little bit, like to people like me. I don't know how many times I've made this particular mistake. So the first thing that I do when I find myself trapped in an infinite loop, that's what I actually look for, is did I mess up with a minus minus versus plus plus. All right, the other really common loop error is what's called the off by one error. So an off by one error is, should you start something here? Should it start at 0 or should it start at 1? And if you make the wrong choice, then the number of years that you live in this loop is likely to be off by 1. Over here, should it be a less than or a less than equal? If you make the wrong choice, it can happen that you might be off by a year. So these are very, very common errors. And there's only one way of solving them, and that is simply to try every possible combination. So the way to solve it is to walk through the loop with some typical test cases and see what should be happening. So here's a typical scenario where we can find the stuff out. So and when you do the simple scenario, pick values that make your computation easy and that don't change the character of the loop. So here I said I'll start with $100, and I use the interest rate of 50%. You know, we would all love to get that interest rate, but it makes it real easy to compute this. So after 1 year, the balance is 150, and so if I quickly make a diagram here that shows what happens to year balance. At the outset, year was initialized with 0, balance was 100. Then year got incremented to 1, the balance is 150. Now 150 is less than 200, so I enter the loop again. Year is now 2, and the balance is now 225. Then 225 is greater than 200, so I exit the loop, and the year is 2, which it should have been because for 2 years I had to labor to get that double balance. And so that verifies that 0 was really the correct initial value. Now, the less than versus less than equal is a little bit tougher to do in this particular loop. Often it's easy, but in this particular loop it's a little tricky because what's your chance of hitting the equal exactly with interest rates? You've seen in the previous examples, particularly if you use like 5%, the values get ugly pretty quickly, and you get 100, 105, 111 point something, or the chance of getting exactly 200 seems pretty low, except if you set the interest rate to be a whopping 100%. Then that way you'll get exactly from 100 to exactly 200. So let's try that. So in our walkthrough, we have year and the balance. The interest is now 100%. Year starts at 0, balance starts at 100. 100 is less than 200, so we enter the loop. Now we add the interest. Year is now 1. Our balance is 200. Now, the question was, should I go one more time in the loop? And I shouldn't, because my balance has doubled. And so that means over here, the less than really is the right choice, because when I have 200 and here I have 200, then I don't want to go in anymore, so the less than was the right choice. So with these two sample scenarios, I've settled these two questions. All right, so what you've just seen me doing is this general strategy of tracing a loop. We've already traced some statements in the previous exam and in the lab, and this is kind of the bread and butter of figuring out what a loop does. You want to do it on a sheet of paper, write down the values that you know. Whenever one of the values gets updated, cross out the old one and write the new one under it. Now, technically speaking, you don't have to cross out the old ones. You could just always look at the lowest value, but somehow it seems oddly satisfying to cross them out. So we'll do that. And it's also a good idea, particularly as your loop gets more complicated, that on the sheet that you see the loop, that you have like a little paper clip or something that moves around so that you know where you are. If the loop is very simple, you don't need that. But as the loop gets long, that's kind of handy. Now, some or maybe most of you have already done that loop lab where you've tried that out with a simple loop, so you're kind of familiar with that. So let's have a concrete example, the loop over here. So when you look at this loop, for most of you, it's probably not very obvious what it does. So if you were to look at this loop here, could you tell in an instant what is the value of sum after the end of the loop? So it turns out that most professional programmers who've been programming for a few years, when they see this loop, they say, sure, it's 19. But it's going to take us a while to get to that point. So the interesting analogy is that when an expert chess player looks at a chessboard from some game, and you ask them to look at that chessboard like for a second or so, and then you ask them to set up, then you move it away, and then you ask them to set it up again or to write it on a sheet of paper. A professional chess player can do this. They can look at a board for a second, and then they can recreate it. They can tell you what that board was. But only if it came from an actual chess game. If it's a random board, they can't remember it either. But so as you get better at these things, one can start discerning structures in these loops that you say, oh, this is a kind of loop that I've written many times before. But right now, there's no way that a beginner can possibly do this, or should be able to do it. I mean, it just takes a few years of study. Instead, the beginner's tool to understand the loop is to trace it. So the tracing is a little bit tedious, and people don't like to do it, but it is stunningly effective. So let's just trace this darn loop here. So we are, we are here. Let's see, is n greater than 0? It is, it's 1729. So we compute digits. It's n mod 10. What is n? N is 1729. What happens when you do mod 10? The last digit. So in this case, it's the 9. Sum is sum plus digit. Sum is 0 right now, so now sum is 9. N is n mod, it's n divided by 10, so that means it's 172, and because n and 10 are both integers, you throw away the fractional part. So n is greater than 0. Digit is now 2. Sum is 9 plus 2, which is 11. N is n mod 10, which is 17. It's greater than 0. You do it one more time. 17 mod 10 is 7. The sum plus 7 is 18. This one divided by 10 is 1 because we throw away the 0.7. 1 is greater than 0. The last digit of 1 is a 1. We add that here. That's a 19 now. Now what's 1 divided by 10? It's 0 because you throw away the 0.1. 0 is no longer greater than 0, so we get into this line here. We print out 19 as the answer. Now after you've done this, you can tell me in plain English, what does this loop do? In 10 words or less, what does this loop do? Okay, so let's look at it again. We went through, we extracted the last digit, and we added it into the sum. And then we stripped off the last digit. Now what's the last digit is no longer the last digit of the number, it's what's the next one after. Remember, we started with 1729, reduced that to 172, to 17, and to 1. So we kept losing that digit that we previously added up to sum. It's the sum of all digits. So this loop computes the sum of all digits. So what we achieved with the tracing is we got from something that looks like a totally random loop to a loop where we now know what it does. It sums up the digits. So by computing that mod and division, it's a nifty way of going through all of the digits one at a time. And then we can do with them what we want. In this case, we're summing them up. Without the tracing, I think it would be very hard to come to that conclusion. Questions about why this loop sums up the digits? I'll be glad to go over it again. It's important. So if you find this hard to believe, you need to do this yourself. Get out a sheet of paper. Choose a different number, not 1729. Pick your favorite number, and run through the loop, and then you'll see with your own eyes how that works. All right. So I'll have you do this with the different loops. So let me set up the question. All right, let's see what's the first digit here. So we come in and it's 1729. 1729 mod 10 is the last digit thereof. The remainder by dividing, so that's the 9. Result is result plus digit. Now result is a string. Can I add a string and an integer? What happens?
It gets converted to a string.
Yes, so the integer gets converted to a string and the two strings get concatenated. So result is the empty string, and I concatenate the string containing 9, so now I have the string containing 9. N is n divided by 10, so that's 172. I go through the loop again, because it's bigger than 0. The digit now is 2. So now result equals result plus digit. So I concatenate 9 and 2 for the string 92. And n becomes 17. From the statement over here. Now I say it goes into the loop. Digit is 7. So that gets concatenated to here. N is 1, then the digit is 1. N is 0, and I leave the loop. So the answer is 9271. See how everyone did. And so that was the majority answer. And so, but a minority thought there was a syntax error. Let me double check whether there was a syntax error. You never know. Nope. Since we're at it, we might as well run it. And here you have it. All right. I saw a question here pop up saying, clicker question 2 is closed already. So I couldn't help notice that some people were kind of waiting until after I gave away the answer before they submitted their answer. And now that I figured out how to close these polls, at some point I do close them. So you shouldn't be waiting forever to put in your answer. Remember, it doesn't matter what your answer is. You get a point for every answer, whether right or wrong. So you may say, so why am I making it so that it says show votes? Because if I don't, Piazza won't count it. So it only counts those contributions that are not anonymous. And so this way it's counted. I'm not going to go and labor through there and say, oh my God, all these people gave the wrong answer. So neither am I going to go say, oh, how wonderful, these people all gave the right answer. I do actually have other things to do in my life. All right. So on aggregate, one hopes that most of you will give the right answer most of the time. So here we have another one for practice. Oh, this is a beautiful question. All right, let's get this one going. This will take you a couple minutes to trace through. All right, let's see how people are doing. All right, so the majority of people say it's answer number 2, and that's, if you watched me, what I was doing, that's the same answer I got. And so the thing that made this a little difficult to predict is we're keeping going while I is greater than 0, and so when I is 0, we don't get the first character, so that's why the H doesn't get picked up. If I had said here while I greater or equal 0, then it would have picked up the H as well, and then it would have perfectly reversed the string. As it happens, it missed the reversal by 1. We don't quite know what this code was good for, but if its job was to totally reverse the string, then it was off by 1. Let's see, a few people, a good number of people had this one here, so you must have been off by the string index. So what I always do is I write the indexes in small letters under it. I mean, it takes only a second, and then as you have to remember so many other things, it makes it easier to look them up. All right. So the other thing I wanted to show is how to get more practice with these loops. So loops turns out to be the great dividing line in the course, that the people who get past loops will pass the course and go on and become software engineers. And the people who have trouble with loops tend to struggle a lot and come to me and say, what can I do? And I tell them the same thing, and that is practice, practice, practice. It's the only way to do it. So how can you practice? As it turns out, there's a bunch of websites that have these practice problems. So I like this Coding Bat site. It has a bunch of Java problems, a bunch of Python problems, which we don't care about. So when you go here to all Java sections, then it's particularly strong later when it comes to arrays. But they do have a number of loop problems. So they're kind of a little bit hidden right now in strings. So what we want to look at is medium string problems, 1 loop. And so let's look at double car. Given a string, return a string where for every character in the original there are 2 characters. So the turns into the and so on. So how do we do this? So we need a loop through all of the characters in a string. You already had this in the lab, and we already had kind of a loop like that in the, where is it now? The heck is the lecture? Okay, I can find it in the lecture right now, so I'll just type it again. Let me make it bigger. So at this point, you kind of have to know the basic loop on how to traverse all characters in a string. And here's one way of doing it. So that gets us to all of the characters in the string. So I'm just extracting the ith letter. It's the substring that goes from I, but not quite to I plus 1. And you have the choice, do you want to have it as a string or as an individual character? We'll talk about that in the next lecture. Now, what am I going to do with those letters? So now you have to have the idea that you want to accumulate them somehow. You want to stick them all into a result. So that way you would come up with a string result, start out at the empty string, and at the end we're going to return that result. Well, we haven't covered it yet, so I'm going to do it with a while. So, and in each step, what I want to do is I want to take the result and add to it the letter and the letter one more time. That way I get every letter doubled. And so let me click on go. And nothing happened. So maybe I need to make it smaller. Yes. And you see back here it says all correct. Instant happiness. It's unlikely that when you try it for the first time it's all correct. More often than not there's some kind of an error. I'll just simulate how this might happen. I'll put a space in here and I get them all wrong. Not so great, but so you get this instant feedback and you can look at what's happened here. So it really is very good practice. Now, it works particularly well if you already know how to do this, like what I just did. But when you don't, it really kind of calls the question, how do I get going with this? And so you have to say, with a string, how do I visit each letter of the string? How do I accumulate a result? And after a while, these various bits and pieces of strategy become second nature. But it takes a while for them to become second nature. So I totally encourage you to go to this site, try it all out, and practice with this. There's another one that I put up that's kind of in beta right now. And you'll recognize what it is. It's actually, it's the same thing as NetBrat. But if you go to these code completion problems, see we're in chapter 6, and for example here we go to count sevens. This problem says count the number of digits with value 7 in a given number. We've just seen how to go through all of the digits of a number. The basic loop looked like this. And while n was greater than 0, this one is not as nice with the formatting. Digit equals n mod 10. N equals n divided by 10. This loop here will set digit to the last digit, then the next to last, and so on. And since for counting how many of them are 7, it doesn't matter in which order they come, this one works great. So how do I know how many of them are 7? The trick here is to take a counter and increment the counter every time that you find a 7. So now, of course, we have to actually declare this counter. And return it. And so let's submit that query. And now it looks pretty much like encoding batch. You get the test cases here. And the rest of it is that very familiar display from NetBrat. So both of these sites work pretty much the same way. The coding bad one has more problems. The NetBrat is more for homework problems, and this kind of thing has come as an afterthought. But these problems are, of course, very closely related to the book. So you may want to look at both of them and try which ones you like. This one here, stutter turn, is similar to the one that you've previously seen. This might be a good thing for you to do at home. We are asked to replicate every T. Not every letter, but just every T. All right, so go and do these practice problems. They are incredibly useful. I'm not going to assign them because some of you need them, some of you don't need them. You probably know if you're amongst those who need them, and that is what I just totally recommend to do to practice. So I've seen a Piazza thing pop up where someone had a question about the homework 7. So whoever that was, if you could please put up that question again on Wednesday, or like move it up or somehow that when I come in on Wednesday that I see it. So Wednesday, come up with questions for that homework. It's a hard homework.